Alright, now that we've set up our free list, at first all we have in our array, this is like stage number 1, right? At first all we have in our array is the free list, right? And we don't have anybody standing in the line. Therefore the head is null and the tail is null. Remember, head points to the start of the queue and tail points to the end of the queue. Since we do not have anybody standing in the line, therefore head is null and tail is null. Okay, let's go to step number 2. Step number 2 shows this shows a different situation, right? And this is where we have one person standing in the line, right? And that person obviously is now at the head of the queue, and since he's the only person standing in the line, he also happens to be at the tail of the queue. So both the head pointer and the tail pointer are pointing to that very person or that very node which is in the queue, right? Because we don't have another node in the queue. So this is our head and this is our tail. And obviously what you can see here on the right hand side is that now our free list has 3 nodes, meaning that this node was actually taken away from the free list, right? So this was taken away from the free list. So our free list initially had 4 nodes, right? Initially it had 4 nodes, but now that a person has joined the line, one node has been taken from the free list and it has now become a part of our active queue. Okay, let's move on. Situation number 3, right? Situation number 3. Another person joins the queue and the second person is Umar, right? And Umar joins our queue or our active line at the end of the queue, right? So Ali is still at the head of the queue and Umar is at the end of the queue, and obviously the head of the queue is marked by the head pointer and the last node in our queue is marked by the tail pointer. Obviously this new node that has been added to our queue has been taken from the free list, right? So our free list previously had 3 nodes and now it is left with 2 nodes. So you can see that as the size of the queue is growing, the size of the free list is becoming smaller. Okay, let's continue further with this. Let's see. Okay, from situation number 3 we go to situation number 4, right? And let's see what is happening here. Now we have 3 people standing in the queue. Ali, who was originally there in the queue, then came Umar, who is now second in our queue, and then came Asim, who is the last person in our queue, right? So obviously Ali is still at the head of the queue and the last person to join Asim is at the tail of the queue, and you can see from our head and tail pointers that they are pointing to the nodes at the start of the queue and at the end of the queue. And once again, previously we had 2 nodes in our free list and we've taken 1 node because we've added Asim to our queue. Therefore the free list is now left with a single node. Okay, let's go to situation number 4, right? Situation number 5, sorry, from 4, and this is where another person joins the queue and his name is Faz, and obviously Faz, he's been added to the end of the queue and we can see that the head pointer is correctly pointing towards Ali and the tail pointer is pointing towards the node in which, towards the last node in our queue, right, where Faz has been added to the queue. And obviously we only had 1 node available to us previously, and that 1 node has been taken away by Faz, right? Therefore our free list is empty now. Our free list does not have a node inside of it, and we can see that, right? The free list pointer has been set to null. So this indicates that at this point we do not have empty nodes left. So now in this situation, if somebody else wants to join the queue, he'll not be able to join the queue because our free list does not have any nodes available, right? The free list pointer is pointing towards null, which means we do not have any free nodes available. So this is the maximum size of the queue that we can have, right? if a new person wants to join the queue, he'll not be able to join the queue because our free list pointer is null. There are no more free nodes available that we can take away from the free list. So it's time now that we start writing our code. What we've done is, what we want to do is, rather, we want to write a procedure with the help of which we can add a node to our queue, right? Queue would be the active line where people come in and stand, you know, one behind the other. So we want to write a procedure that would help us add a node to the queue, right? And what we've done here is that this is the header, right? And you know, this first line where you declare a procedure, this is called the header of the procedure, right? So this would be the header of the procedure. And so what we're doing here is we've said that this is the identifier, right? The name of our procedure is join queue, and we are passing a string value as a parameter, right? So and the identifier of our parameter is data item, right? So this would be the identifier of the parameter that we are passing to a procedure. So in short, what we've done is we're going to write a procedure called join queue, in which we are going to pass a string value, and this would most likely be the name of, you know, the person who's going to come and join the queue. And if you remember, you know, we declared a node, right? And in the node we had two items, right? Two data items, two fields. One of them was name and the other one was PTR. So this string value, we'll take this string value and we'll eventually assign it to the name field of our node. Okay. Now that we've understood this, let's take a look at what we need to do. To add a node to our queue, these are the two situations that we must consider. You know, this would be situation number 1, and in situation number 1 we don't have an active queue, right? All we have is a free list. Okay, that would be situation number 1. You know, when we don't have an active queue, when there's no one standing in the line, what should we do? That's one situation for which we have to write code. And the other situation for which we have to write code, number 2, would be this situation when there are already people standing in the queue, and you can see, you know, there are 2 people standing in the queue right now, right? When there are already nodes that are there in the queue, how do we add a new node to the queue? Okay, so in situation number 1, when there are no nodes in the queue, how do we add a node to the queue? And in situation number 2, when there are already some nodes in the queue, how do we add a new node from the queue? These are the only 2 situations that we need to worry about. Okay, one thing that we should be very clear about is that we cannot add a node to our queue if we don't have any free nodes available, right? So one of the first things that we want to do once we go inside our procedure, one of the first things that we want to do here is that we want to first check if we have free nodes available. And the way to do that is that we're going to check if the free list pointer is not equal to null. If the free list pointer is not equal to null, that means we have some nodes available to us, right? And therefore we can take a node from the free list and we can add that node to our queue, right? So this check is very important. So what we are checking here is, are there free nodes available, right? This is what we are checking here. Okay, so that is exactly what we're doing here. We've checked that if the free list is not empty, if the free list pointer is not null, then what we're doing is that we have set up, we've declared an integer variable, we've called it the new node pointer, and what we want to do is we want to take a node away from the free list and we want to take and we want to add this node to our queue, right? So to be able to take the node away from the free list, what we want to do is we want this new node pointer to point to the same location that the free list pointer is pointing to, right? So this is how we do it in the code, right? What we're doing here is that we want the value of the new node pointer to be equal to the free list pointer. Remember, the free list pointer is always pointing to the location within our array, right? Our array has several elements, and the free list pointer, right, the free list pointer points to the location in our array where the first node of our free list is lying, right? So it points to the location in the array where the first node of our free list is lying, right? And remember, you know, this is the name of our array, right? So what we've done is that we've made the new node pointer point to the same place by using this statement. So what we're doing is that we have two pointers pointing to the same place, and what we can do now is, because the new node pointer is pointing towards this place, we are going to steal, or we are going to take away this node from the free list, right? And we're going to make this free list pointer move to the next node, right? Because it has to release this node, this has to be added to the queue. So we'll have to make the free list pointer point to the next node, and the next node is the node that this node is pointing at. This node is pointing, as we can see here, this node is pointing towards this node, right? So this is the node that we want the free list pointer to point at, and this is the value, you know, this PTR value is basically pointing towards this node, right? So we want our free list pointer to take this value, and when the free list pointer takes this value, then the free list pointer will also be pointing towards this node. And what you can see here is that what we've done is that we've moved the free list pointer now. Okay, we've moved the free list pointer, we're giving it a new value, and this new value is equal to this right hand side. And what are we saying here? We are saying that go to our array called queue, right? Go to queue, and within queue go to the element that the free list pointer is pointing at. So remember, the free list pointer was pointing somewhere here, right? So go to this location, and within this location you will find a node, right? Within this location you will find a node, and this node has two fields. The first one is called name, and the second one is called PTR. So what we are saying is that go to this location queue, go to the element given by the that the free list pointer is pointing at, and take the PTR value there, dot PTR, right? Dot PTR means when you use the dot operator, you can either choose this field or you can choose this field. Using the dot operator here, what we have done is we've taken the PTR field. So what we are saying is that in the array queue, at the element pointed by the free list pointer, take the PTR value and assign that PTR value to the free list pointer. So what effectively that has done is that the PTR value, the free list pointer, is pointing to the same location that this PTR is pointing towards, right? Okay, so what this means is that the free list is now starting from this location. It's now starting from this node, right? Because the free list pointer is now pointing to this node, right? And this node is now being pointed to by the new node pointer only. So we only have one pointer towards this node now. The free list pointer has moved to the next node. Okay, let's move further. Let's see what we are doing here. What we're doing here is that once we've done these three steps, you know, these three steps we've already discussed, we want to set up our new node pointer, And what we've done here is that in our array Q, at the location that the new node pointer, at the element that the new node pointer is pointing at, there is a node, right? And out from that node, what we've done is we've taken the name field, right? So in our node which is lying at this location, the node that is lying at this location, right, its name field, the value of the name field is being set to data item. And you should remember that this was the parameter that we were passing, data item was the parameter that we were passing into our procedure, right? See this is data item, right? This was the parameter that was being passed in the procedure. So we are assigning the value of this parameter to the name field of our node. So we are assigning the value of this parameter data item to the name field of our node towards which the new node pointer is pointing. Okay, I hope this is clear. And what we are doing here is that for the same node that the new node pointer is pointing at, its PTR value is being set to null. And remember, when you take a node and you want to add it to a queue, this node is always going to be the last node in the queue, right? So there is no, it's not going to be connected to any other node behind it, right? There's nobody going to be standing behind this node, right? There's going to be no next node. Therefore, its PTR value is always going to be null, right? So for example, there was this person A standing in the queue. Now if there's a person B who comes and joins the queue, then what happens is that A will be connected to B, and B, since this has recently joined, there is no one behind B, right? So B will be equal to null, right? B would be equal to null. The pointer value, the pointer value of this node is going to be equal to null. Not B is equal to null. B is the name of a person, right? So the pointer value of the new node is going to be null. Okay, so this is what we've done so far. We have set up our new node, right? Our new node is now ready to join the queue, and we have basically taken this node from the free list, and we can see that the size of the free list has now been reduced by one node, right? So previously it had 4 nodes, now it has 3 nodes. So what we are going to do now is we are going to take a look at the two situations we discussed earlier. Remember, this was the first situation, and in the first situation we do not have a queue, right? But the head pointer is null, which means we don't have a queue. This is the first situation, right? And now we are going to discuss the first situation. What are we going to do when the head value is null? When the value of the head pointer is null, that means we don't have a queue, right? So if head is equal to null, what are we going to do? If head is equal to null, then what are we supposed to do? Remember, if head is equal to null, then that means that this is the first node in our queue, and this is also the last node in our queue, which means what? That the head pointer should be pointing towards this node, and the tail pointer should also be pointing towards this node. And you can see that this is what we've done here, If head is equal to null, what we've done is we've set our head pointer to new node pointer, and we've also set our tail pointer to new node pointer, right? So both the pointers, both the head and the tail, are now pointing to the same node. Let's now consider situation number 2. In situation number 2, we already have a queue, right? And what are we going to do if now we get a new node that we have to add to this queue, right? So in situation number 2, we already have a queue. There are already people standing in the line. There are nodes in the queue. How are we going to add a new node to our queue now, right? Remember, the new node is always going to be added to the end, right? So this is where the new node is going to be added, right? And the tail pointer should eventually point to this node, right? This is where the tail should point. So this is the situation that we want to discuss now. Okay, let's take a look, right? Now we have one node in our queue, as we can see from this diagram, right? We have one node in our queue, and we want to once again we want to see if the head is not null, right? Because if in this situation the head is not null, right? If the head was null, what we did was we set up the head pointer and the tail pointer to point towards the new node pointer. But what if the head is not null? What are we going to do in this else situation? What are we going to do now? If the head is not equal to null, which we can see here, then we go to the else clause. What are we going to do now? So what we want to do next is that this new node which the new node pointer is pointing at, right? This is the new node that now needs to be added to our so this is the new node pointer is basically pointing here, because I need to scroll this, so I need to write this again. Let me just scroll now. Okay, so this is the new node that has to be added to our queue, right? And this time we can see that we already have a queue. We have an existing queue. The head pointer is not null, it's pointing towards something. So how do we add this node? Well, one of the first things that we are going to do is we want to link this node. We want this PTR value not to be null anymore, rather it should point towards this node. It should point towards the place where the new node pointer is pointing at. It should point towards the node where the new node pointer is pointing at. And this is exactly what we've done here. What we are saying here is that this node, its PTR value, and remember, to go to the node, first we go to the array queue, and then we use the tail pointer, because the tail pointer is pointing towards this node, so it's pointing towards this node. So in our array queue, the element which the tail pointer is pointing at, right, within that element we have a node, right? And from that node we want to take the PTR value, right? And we want to set this PTR value equals to the new node pointer. What this is going to do is, this is going to just make this PTR value point towards the same location that the new node pointer is pointing at, right? So the new node pointer is pointing towards this node, right? And that is exactly what we've done here. And finally, the tail should not be pointing here, right? The tail should be pointing towards this node, right? And what we've done here is that this is exactly what we've done. We've made our tail pointer point towards the location where the new node pointer is pointing at, right? So this is what we've done. Tail equals new node pointer, and that basically is what we need to do in this scenario. So we've covered the entire piece of code for we've covered both the situations that we wanted to cover, when situation 1 when there was no queue, and situation 2 when we already had nodes in the queue. These are the only two situations that you need to cover when you want to add a node to the queue. I hope your concept is clear now. So finally, this is the complete procedure, and what we can see here is that on this line, this is where we're checking that do we have some nodes available in our free list. If the free list pointer is not null, the first thing that we do here is we do this, right? We set up our new node, and steal it or take it away and steal it from the free list, right? the free list pointer is also moved to the next node, right? So these are the things that we are doing right here in this statement, right? And once we are done with that, then we check this if statement, right? In this if statement, what we're doing is we are adding node to our queue, or you can say line, right, when the line is empty, right, or has no nodes previously, right? So it doesn't have any nodes previously, right? So this was an empty line, and when we have an empty line, or an empty queue, the head is equal to null, and in that situation, what do? We do these two things, right? These are the two things. We set the head pointer and the tail pointer to point towards the new node, and this is the else case, right? Otherwise, if queue already exists, if we already have nodes in our line, right? If queue or line already exists, then these are the actions that we take, right? This is what we do. Okay, I hope that you've understood how we can add a node to the queue.